Hello, everyone. My name is Jason, and I'm the co-founder and CEO of Trillion We are probably the smallest company in the world that's building the largest open source from scratch LLMs in Korea. So it's a really honor to be here presenting in front of everyone. I've done the same talk at GTC at NVIDIA early this year, and it's a much more packed environment, so I'm really happy to see a lot of people. So some of you may already know about me. Oh, okay. I don't know why it's not going. 넘어가지 않는데. 네. Okay, there was a slight technical issue. Sorry about that. So some of you already know about me, some of you don't. So I don't like to brag about myself, but to briefly talk about myself and our company. I've been a researcher in NLP and large language models before they were even called large for a decade. And I've been leading a lot of frontier research work on LLMs and evaluation. And my most impressive, I think, career would be that I've been the lead researcher and core researcher at HyperClova X for about a year and a half. And I realized that it's a crazy time. It's a really AI frenzy. It's really crazy to not build an AI startup at this time. To briefly talk about my company, we were founded in Korea, so we raised around $6 million in pre-seed. I think it's a pretty big amount of money that's unheard of actually in the Korean AI scene. And it's been a year and a half, and we've released a lot of models since then, and we're doing a lot of frontier research work since then. I'll talk more about this in the later slides. Okay, so the challenge that we face as a small company is very simple. LLMs are clearly transforming the industry and how people work, how we live, but the entry barrier of building LLMs is still enormous. For example, we still require trillions of tokens. We still need millions of dollars in compute and petabytes of infrastructure. And that's typically only affordable by these large companies like OpenAI, Google, Anthropic, and Meta, and you name it. But I was thinking, what if we could build it differently? Because I wasn't able to do that at Naver, actually. How can we do it faster, cheaper, and more open? Because I was thinking openness is actually very key. And these questions actually became the foundation of Trillion Labs, which led me to actually start this from scratch LLM journey. So when I first started Trillion Labs, a lot of people asked me, why build Korean LLM and why do it from scratch? There's a bunch of open source LLMs out there. Why not just take it and why not just fine tune it for whatever use case you want? And I was thinking, that's a very stupid question. Because if we want to truly customize models, you actually need to have full ownership of the data and the model weights. And I was thinking that's actually a very, very small use case in the future. And I think my predictions are turning out to be true. If you look at how Korean government is sponsoring sovereign AI right now people ask me a different question. You only raised $5 million. Did you actually do it? So that led me to think maybe we should open more on what we do. So which is what we did, actually. We did radical openness, which I'll talk about later, of all the models you see here, from 0.1B to 5B, 1B, and 7B to 21B, and our largest frontier scale, 70B. And it took us only a year to develop all this full stack LLM pipeline with only 11 researchers, including myself. So I'm pretty proud of this. I typically don't like to brag about myself in the company, but my PR personnel told me I should do this. I have a few more slides on that, and then I'll talk more about the tech that we're building because that's actually more interesting for myself and probably the folks here. So very simply put, there's MMLU and KMLU, which are the key metrics that people use to measure LM performance. We have English and Korean. There's also Japanese, Chinese as well on the back, behind the scene. Basically, we've seen improvements from 20% to all the way up to 90% from our previous models to our latest models. And I want to particularly stress out that our math and coding performance also went up like 60% to 90% based on our previous models, which basically means now we reach frontier scale finally. And these are all our 21B and 7B models you can see on the below legends. More importantly, we did all of this with less than $1 million in total, actually. So for our 7B model, it cost us around 140K. So 140,000 is like eok in Korean. And for our 21B model, which is actually frontier scale, cost us less than $500,000. That's around 7억 in Korean won. So approximately is 10 times to 12 times cheaper than all the frontier scale models you see here with Gemma 2, Gemma 3, Quen 2.5 and 3, which are basically the best models open source that you can check right now. And we not only got the significantly cheaper price, but we also done it with a very similar competitive performance, which is actually the most important thing, that we can do much better with more capital. And all of this is possible because of the tech that we built. One prominent tech that I want to brag about is our cross-lingual document attention, XLDA. It's our proprietary innovation. Very simply put, we were able to use less than 10% of the required amount of Korean data than other Korean models out there that use, let's say, trillions of Korean tokens. We only use a matter of billions. So it's a magnitude order of less data than we actually required. And the reason we were able to do that was because of a new attention mechanism that we call XLDA that allows us basically an effect that generating tons of synthetically paired cross-lingual data. So there's a lot of technical jargons here, so I'm going to skip that. I have a full talk, 20-minute talk about this at NVIDIA GTC, so you can check that out. But basically, very simply put, we were able to achieve 10x higher training efficiency with this because we were able to use 10 times less data and 10 times less compute. So these are the kinds of innovations that allow startups like us with significantly less funds to actually make innovations and compete with frontier scale startups, frontier scale companies. Another thing that I want to point out is that we became the first for-profit organization in the world to open source every intermediate checkpoints out there. So this is actually pretty big. So the only companies out there that did the similar thing is LlmAI, which is a nonprofit research organization, and Hugging Face. So I'm pretty sure some of you already know about that. But what we did basically is we released the intermediate checkpoint weights of LLMs from starting all the way from the very first random baseline all the way to the fully pre-trained version. So this allows researchers and developers to do a ton of research and development work that is just unheard of. Full customization becomes possible. And more importantly, what we did is 100% reliable. We basically opened up the LLM recipe for the whole world, all the way up to 70B. And nobody has done that before beyond 20B scale, and we're the first to do that. The biggest reason I wanted to do this is because I believe in open intelligence. I believe that AI is going to change the world. It can be doing magnitude of good thing, it can be doing a lot of bad things, but more importantly, I think that if we keep it open and the recipe open, we can keep it safer for the world. Good side effects is that a lot of people believe us now that we are actually doing some important things. Finally, this is actually research that was enabled because we opened all the intermediate checkpoints. It's called R-Bridge. This is our most recent open source release. So this is basically not a model, it's a methodology to train the models. I told you earlier that we have a bunch of trade secrets behind the scene that allow us to train models much cheaper. This is one of them. So a lot of research from DeepSeek, from Google, OpenAI, on pre-training basically converges into scaling law research. And none of that actually has been published in real training environment. It's all in academic environment. And we actually did it in a really real training environment, production level. And we've specifically focused on reasoning models because that's the fuel for agentic AI these days. So what this research is about, very simply put, if you want to train a large reasoning model, you would typically need a very large proxy model to predict the performance of it. What we wanted to do is, can we train a very small proxy model, like 100 times smaller, to predict large reasoning model performances? And using R-Bridge, we have a whole full paper on this, I won't dive into details, we were able to reduce that, not only make that possible, but make it really cheaper. 100 times cost reduction in recipe ranking, up to 700 times compute efficiency when we actually want to train the models. Putting aside all the technical jargons, what we basically did, if we can train a large model, if we can predict a large model performance without actually having to train it, that would save a ton of money, basically. And that's what we're doing here. And we focus specifically on the reasoning performance, which was not possible before, and our new method allows us to do that. And these are the kind of innovations that we wanted to highlight when we actually say we're doing cost-efficient pre-training, and we're the most cost-efficient frontier AI lab. So long story short, we scaled up to the shortest, most optimal path to frontier technology. Starting in 2024 August, right now it's October 2025, so it's been only a year and 2 months. And we've been actually really thriving on a lot of these research. And we have much more exciting research going on, and I'll talk about some of them in the next slides. So a lot of people ask me, you built models now, and when I was first starting the company as well, you built models, what are you going to do next? And I believe what next is still going to be models. A lot of people talk about all the value is going to be in the application layer. You got to build applications like Perplexity, like Cursor, wrap around all the OpenAI APIs and build your own custom remote or whatever. People tell me that, and I don't buy into any of that, actually. I believe there's some truth into what they say, in that application layer will capture all the value more than the model layer right now. But I believe OpenAI and companies like us, Trillionlabs, Anthropic, will thrive and actually capture all the application layer as well. And you can see from Perplexity and Cursor building their own models to be independent of these companies. And you can also see it from OpenAI and Anthropic building AI agents, which are B2C products and B2B products as well. So essentially, we're going to keep building models, and we're going to build better models. And this time, we're going to make it more specialized, not just generic. And this is how I believe AI will change in the future. AI essentially evolves in a way in the order of abundance of data. So basically, if we have more data, that's the first domain that will be solved. And that data obviously has to be more accessible. So we've solved language. OpenAI solved English. DeepSeek solved Chinese. We've solved Korean, Japanese. Math and coding is being solved right now, along with science. And the next stage is obviously virtual AI agents, not physical AI, because there's not data there. There's no good simulator. There's no good environment for that. And I believe it's going to be virtual AI agents that's going to come first. A very, very simple evidence of this is you can see all those AI web browsers right now. You can see Gemini for Chrome, Cloud for Chrome, OpenAI Atlas. And these are all examples of frontier AI labs rushing towards that web browsing automation agent. And Perplexity said they're going to buy Chrome for $35 billion, which is even actually twice their valuation. So all these crazy stuff are happening because this is where all the value is going to happen this is the next battleground, basically. Now, one interesting thing that you can see is that no one's doing it for mobile devices, like phones, basically. And I believe that's definitely there's many reasons behind that, but Apple is the biggest reason people aren't doing it for mobile devices. In Korea, we have Samsung, so it's easier. There's Android. And I believe that LLMs and AI agents will change how we use our devices, including web browsers and computers, but also, more importantly, on the phones. Phones are essentially our second brain, right? And that second brain is becoming harder and harder to use. For example, I have 500 apps installed on my phone, and I don't use most of them. My mother, who's been using a phone for 20 years already, still can't call a taxi on Kakao T. I'm pretty sure some of you might resonate with that. So my belief is that phones are going to get harder to use and better and better, but harder to use because there's going to be more apps. There's got to be some centralized interface, and AI is going to do that. And that's what we're going to build. But the problem is there's no model that can do that right now. And that's essentially why companies like us need to be around, stick around, and build those models. And that's the gap I see right now. So essentially, we're building 100 times better Siri. And we're doing that with these three keywords that I talked about today: data efficiency, compute efficiency, capital efficiency, and open collaboration. Basically, our Apache 2.0 licensing and our checkpoint transparency gives us more credibility, but also gives us a very good brand among developers, which will be our initial customers probably. And in short, we're able to overcome our capital restrictions and be more creative with it. Finally, I want to talk about what Trillion Labs, the name means and what it stands for. Some of you might be curious about it. The first T is about trillion tokens. I thought that, okay, we need trillions of tokens to train LLMs, so definitely that's a good name. But the next T is actually trillion parameters. There's no trillion parameter models out there, at least on dense level, except mixture of experts. And I believe that we'll be one of the trillion. There's definitely going to be a time where trillion parameter models are going to be the norm of the models we have. And third is we want to be $1 trillion company one day. So thank you.